This is Electromagnetism Lesson 8, and we're going to do the transformer equation. So by the end of this, you should be able to recall the transformer equation. We're going to apply it to solve example questions, and then we'll work through a selection of exam-style questions. All right, let's move on. So the voltage induced in the secondary or output coil depends on two things: the number of turns on the primary coil and the number of turns on the secondary coil. It also depends on the primary voltage. So remember, a step-up transformer has more turns on the secondary coil, which increases voltage, and a step-down transformer has fewer turns on the secondary coil, which decreases voltage. So what I'm going to do now is give you an equation. We'll do a couple of example questions, and then we'll try some examination material. Right, so this is the question that we're going to look at. Obviously, first of all, we need the equation. So the equation is relatively straightforward. It's the voltage on the primary coil divided by the voltage on the secondary coil is equal to the number of turns on the primary coil divided by the number of turns on the secondary coil. So that's the equation. So what you can do, by the way, the units, obviously voltages are measured in volts. Number of turns is simply, whatever your answer is, turns. So 200 turns, 400 turns, whatever it is. If you want to have a go at that now, that's fine. It's also an example, so I'm going to take you through it now. So a transformer has 200 turns on its primary coil, 50 turns on its secondary coil, and the input voltage is 920 volts. So is it a step up or step down transformer? Well, it's going from more turns on the primary coil, so it's got 200 turns, down to 50 turns on the secondary coil, so it is a step down transformer. And what is the output voltage or the secondary voltage? So what we need to do is rearrange to get voltage secondary. So an easy way to do this, we can, well, with an equation, whatever you do on one side, you can do anything you want as long as you do it to the other side. So first thing I'm going to do, and a good technique, is to flip both sides. So we end up with voltage secondary divided by voltage primary equals number of turns on the secondary divided by number of turns on the primary. So we flip both sides, and then we just need to get Vs on its own. So we've got to divide by voltage primary to get rid of. The opposite of dividing by voltage primary is to simply times by voltage primary on the other side. So voltage secondary is equal to number of turns on the secondary times voltage primary divided by number of turns on the primary coil. So that'll be number of turns on the secondary is 50 times voltage on the primary, which is 920, divided by number of turns on the primary, which is 200. So if you calculate that, that'll give you the secondary voltage, which is 230 volts. All right, let's try another one. So, if you want to pause and have a go at this one, a transformer has 100 turns on its primary coil, input voltage of 35 volts, and an output voltage of 175. So is it step up or step down? So it's going from 35 volts to 175 volts, so it's stepping up in voltage, so it's a step up transformer. And then we just need to calculate how many turns are on the secondary coil. So the equation, voltage primary divided by voltage secondary is equal to number of turns on the primary divided by number of turns on the secondary. So we want NS, number of turns on the secondary coil. So because it's on the bottom, we should flip both sides. So voltage secondary divided by voltage primary equals number of turns on the secondary divided by number of turns on the primary coil. Then we just need to get rid of a divide by MP. So the opposite of dividing by MP is timesing by MP on the other side. So voltage secondary times number of turns on the primary coil divided by voltage on the primary coil will give us number of turns on the secondary coil. So voltage secondary, 175, times number of turns on the primary, which is 100, divided by voltage on the primary, which is 35 volts. So that gives us 500 turns. Okay, hopefully that's all right. Let's move on. So for these exam style questions, remember to pause, read through the question, answer it, and then I'll take through the answers. So the diagram shows the transformer made by a student. The student has designed the transformer to make a 6-volt light bulb work using a 2-volt power supply. So it's a step-up transformer. So draw a ring around the correct answer. So for a transformer to work, the student must use AC, can use either AC or DC, or must use DC. AC being alternating current, DC being direct current. So we explained in the previous video, the transformers must use alternating current, and that's to give you the alternating magnetic field that cuts the secondary coil and gives you the electromagnetic induction on the secondary coil. All right, let's move on. If you want to pause and have a go at this one. So on the primary coil, there are 30 turns of wire. For the lamp to work brightly, there must be more than 30. What is the transformer core made of, and give a reason for your answer? Straight from the last lesson, should be straightforward. So they're made of iron, and it's because they're easily magnetised, or you could say demagnetized. Now let's move on. So let's pause for this one. So the diagram shows a transformer. So what type of transformer is it? So it's going from more coils to less coils. So it's a step-down transformer. And then just mention the coils. Right, next question, if you want to pause on this one. So why is insulated wire and not uninsulated wire used to make the coils? And then why is the core made of iron? So to prevent short circuits. Why is the core made of iron? Easily magnetised, same question that we've just done basically. Alright, let's move on. Right, so if you want to pause, a transformer has 500 turns on its primary coil and 7,500 turns on its secondary coil. Potential difference across the primary is 150 volts. So I want you to calculate the voltage or potential difference on the secondary coil. So we've got voltage primary. Hopefully this looks clear enough. Divided by voltage on the secondary coil equals the number of turns on the primary coil divided by the number of turns on the secondary coil. And we want the voltage on the secondary coil. So let's flip both sides. I'll do this at the bottom actually. So voltage secondary divided by voltage primary is equal to number of turns on the secondary divided by number of turns on the primary. Then we just need to times through by the divide by Vp. So voltage on the secondary coil is equal to number of turns on secondary multiplied by voltage on the primary divided by number of turns on the primary coil. So number of turns on the secondary is 7,500 multiplied by the voltage on the primary coil, which is 150 volts, divided by number of turns on the primary. So that'd be 500. So calculate that. 2,250 volts. All right, let's try another one. Right, I'll take you through the answers. So a transformer is used to reduce the 230 volts AC mains to the 12 volt supply required for the lighting system, or a lighting system. The transformer is at 1,150 turns on its primary coil. So first of all, let's just say write down the equation. So straightforward. Voltage primary divided by voltage secondary equals number of turns on primary divided by number of turns on the secondary. And we want to calculate the number of turns on the secondary coil. So once again, we're going to have to flip this around. So that'd be voltage of the secondary divided by voltage primary equals NS over MP. So we need NS on its own, we need to make it the subject, so we need to get rid of a divide by MP. So we multiply on the other side. So it's voltage secondary times number of turns on primary divided by voltage primary, and that'll give us number of turns on the secondary coil. Then we just need to put our numbers in. So voltage secondary is 12 volts times number of turns on the primary, which is 1,150, divided by voltage on the primary coil, which is 230 volts. So if you calculate that, that should give you 60 turns. So 60 turns. Alright, let's move on. Let's try another one. Alright, let's go through this answer. So notice on the back of a television set, transformer used in the television set has 75 turns on the primary coil. Potential difference on the primary coil is 230 volts, and the potential difference on the secondary coil is 32,200 volts. So what we're going to do now is calculate the number of turns on the secondary coil. So again, it's Vp over Vs equals number of turns on primary divided by number of turns on secondary. And we need the number of turns on the secondary coil. So we're going to flip both sides. Seems to be a recurring feature. So Vs over Vp equals Ns over Np. So number of turns on the secondary coil, we just need to times through by Np. So voltage secondary times number of turns on primary divided by voltage primary give us number of turns on secondary. Then we just need to put the numbers in. So voltage on the secondary, a whopping 32,200 multiplied by number of turns on primary, which is 75, divided by voltage primary, which is 230, which gives us 10,500 turns. Right, we've got a bonus question, just for fun. Explain how a transformer works. So if you did the previous video, you've done this multiple times. If you didn't do the previous video and don't know how to do it, I advise you go back and watch it. So explain how a transformer works. Right, I'm going to give you the mark scheme. So alternating current in the primary coil. You could say alternating voltage as well. Typically I would go alternating voltage in the primary coil. Gives you an alternating current in the secondary coil. Then you get an alternating magnetic field in the iron core. And then you get your electromagnetic induction on the secondary coil. So you get an alternating voltage on the secondary coil and an alternating current, on the secondary coil. Do not write your answer out like that. That's just because, well, I couldn't be bothered to write it out. But that should be pretty straightforward by now. You've done that multiple times. So I hope you found that helpful, and thanks for watching.